To do these questions, you have a formula, okay? The first thing you got to remember is the volume of a cylinder. Now we're talking about these guys here. That's a cylinder. For those of you that aren't aware of what it is, basically cans are cylinder shaped. So something like this. Okay, cylinder. Now, the height of the cylinder and the radius of said cylinder. Okay. Now, when you unwrap a cylinder and you're looking for its net, do you know what a net is, guys? A net is when, do you remember when you draw a box in 2 dimensions? And do you remember you break it up into 6 different little boxes? A net of a cylinder results in a square, rectangular area and 2 circles, one above and one below. Everybody get that? Now that you've gotten that, what's called the CSA is the curved surface area. To get the curved surface area, the reason why it's called the curved surface area, because when you fold it around, curved, right? Now that's called the CSA, curved surface area. Curved surface area is 2 pi r h. Happy enough with that? No? 2 pi r h. Happy enough with that? What is the area? Now that's only the curved surface area. To get the total surface area, you also have to add on the 2 circles. And how much are each circle worth? What's the formula for each circle? Pi r squared, pi r squared. It's a circle. Yes.
Why is it different? Like rectangle? Yeah, 2 pi r h.
Because it's h high.
Yeah, but why don't you have h for the circle?
The circle has nothing to do with the height. See, the circle is just on the top and at the very bottom. So it actually has nothing to do with the height. It's flat. So it actually hasn't really got height.
So would you not do something like 2 pi or?
I think you're just overthinking it too much. What I really think you should do is just concentrate on the formula for any circle is pi r squared, pi r squared. Do you agree with that? Yeah.
Yeah.
And the formula for the curved surface area, also you have to remember, is the curved surface area is the rectangular part. Its formula is given to you in the notes, which is 2 pi r h. That's all you got to remember. Okay. Now, what happens next, guys, is we have 3 formulas, right? We have the volume equals pi r squared h. We have the curved surface area equals 2 pi r h. And the total surface area is equal to the, anybody? It's equal to the curved surface area plus how many circles? 2. So it's 2 pi r squared. Now, let's begin with each question. I'll do number 4 and number 5, okay? So, number 4 and number 5. Now look, let's look at number 4. What's the pi value? Pi value, anybody? Sorry? Now see the way I'm writing out the workings? The workings have to be done. 3.14 radius squared, 12 squared, times the height, 50. What does it equal? Anybody get the answer? 3768. Is that it?
2,2,608.
I got 22,680.
Okay, stop speaking. 22,680 is perfect. It's in centimeters cubed. Okay, next one. 2 pi r h, yeah? 2 multiplied by, what's pi in this question? What is h in this question? 50. Put that into your calculator and what do you get?
340.
Sorry?
340.
340.
14.
Sorry?
340.
14 centimeters squared. Okay. Now, TSA, guys. What about TSA? Curved surface area is worth how much, guys? Curve surface area, yeah. This one's wrong. What is it? Sorry guys, I forgot to put in the radius, is what Kenny was telling me. He's right. It's meant to be 2 pi RH. So it's 12 times 50. My mistake. And what do you get for that, Kenny? 37? Is that it, Kenny? Okay, thank you. Okay. Lads, the curved surface area is worth how much, Aaron? Curved surface area is worth? Just keep going. Look, CSA, keep going across until you see the answer.
Oh, is 3,768 plus
2 times circle, so you have to get the area of the circle. So what's the area of one circle? It's going to be pi, which is 3.14, and what's the radius squared? Okay, it's not 50, it's 12, okay? And then put that into the calculator, and what do we get?
904.32.
What? The whole thing. It's not 900.
Oh, that's that one.
The whole thing into the calculator, guys.
3312.84.
No.
Plus, wait.
Alright, what do you say, Aaron? 4,600?
4,672.32.
32.32 centimeters squared. Happy enough with that? Now, next question, question 5. Repeat procedure. It's not that big a deal. You just rub all this out and you start again. Exactly the same procedure. Now, this time it's 22 over 7. So pi is 22 over 7. Our radius is, and then our height is 5. Now, put that in the calculator. Take your time. Thank you. Just double check that one, guys. 192.5. Is that right?
Yeah.
5 what? Is it 5 on the start? 5 out?
Yeah.
Okay. Centimeters cubed. What about this one here? 2 pi RH. 2. And what's pi? What's R? What's H? Put that in the calculator and what do we get? Centimeters squared. Your CSA is worth how much, guys? CSA is worth?
110.
Now you got to add on 2 circles. 2 multiplied by, what's pi? Do you understand where I get pi r squared from? That's the area of one circle. The 2 in front of it means I'm going to use 2 circles. Okay? So what's pi r squared this time?
22 over 7.
Yeah.
And then 3.5.
Yeah.
And then
Yeah. Answer?
187.
187 centimeters squared. Now, question 9, guys. Which of the cylinders has the largest volume? Justify our answer. Volume equals what? Volume, anybody? That formula there. Now, what's the radius of the first one? Radius is 30. What's the height in centimeters? 0.5 meters? 50. So it's going to be, we'll just use pi in our calculator, okay? Pi button in our calculator. Pi times radius and 50. Now let's see which one, let's see what it is. Put it into the calculator, guys. Shift pi 30 squared.
Oh, that's wrong. No. Yeah. 4.
45,000 pi.
Yeah.
Press the change button. 141,370. We'll round it up to 372, yeah? 141,372, yeah? Why am I not doing the surface area in this question? Is there any reason why I'm not doing the surface area?
There's no answers for
It's not asking you to, it's just asking you if the volumes of all these. What's the radius of the second one?
20.
What's the height?
50 centimeters. Or sorry, 100.
100 centimeters. So go again. This one equals pi times 20 squared times 100. And what do you get for that? Pi times 20 squared times 100.
You get 4 million.
Really?
48,000.
Pi, press the change button in the calculator.
125,663.
Just call out the numbers. One. So just call them out. 2, call it that way.
Yeah.
Go.
1256.
Slow down. 1256. Yeah.
63.7.
63.7. So 64. Now I was right in saying that the first one was 141,000. Is that correct? 141,300 and centimeters cubed. That was. And the second one is 125,664 centimeters cubed. What about the third one? Change that to 140 centimeters. Half it. And you get?
70.
And what's the height? 10 centimeters. Now, calculate the volume of this one. Pi times, anybody?
70 times 10.
Radius squared, anybody? 70 squared. And then multiply by 10. What do you get for this one?
490005.
Change it.
153,938.04.
So which one's the biggest one?
So, would it stay 38? Because it's 0.04.
0.4.
Yeah, 0.04.
Yeah, so it'll stay 38. Which one's the biggest? The last one. It's actually an easy enough question, isn't it? You just got to change them all to centimeters and then multiply them out.
You have to show the evidence for all of them if that was in a test.
Huh?
You have to show the evidence for all.
You have to show the workings. I keep saying this. You got to do the writing. Yes.
But like it's obvious the third one's the one with the largest.
There's a question here. It has a cylinder contained between two boxes. Okay. Now, what I asked you in the first question is calculate the volume of one of the cylinders. So one of the cylinders looks like this. We're doing an up close and personal view of it. Okay, so there's your cylinder. Just not drawn quite to scale, but you get what I'm doing. Now, guys, what can you say about there you go. What can we say about what are we going to get for the volume of this cylinder? What's the volume formula? Charlie, volume formula.
It's pi squared.
H. Volume formula of a cylinder. Okay. Now, what numbers do we need to put in? Pi is what? What's your radius squared? Has a diameter of 10. What does that mean? That's 10.
Yeah.
What's halfway?
5.
So it has a radius of 5.
Okay.
What's the height?
14.
Okay, put that into the calculator and tell me what you get. What you get?
And 1100.
1100 centimeters cubed. Okay, guys. Now, if you look at the top now, guys, what can anybody tell me how to do question 2? It wants the dimensions of the box that they fit into. Can anybody tell me how would you figure that out? The dimensions of the box.
Would you
Go on, Aaron.
double your answer and then
If you double your answer, Aaron, now Aaron's suggesting we double our answer. If we double the answer, we get all the liquid, let's say that's we get the volume of the two cylinders. But unfortunately, we're also missing out on the red volume that's in the box. Do you know the space that's in between the two cylinders?
yeah.
It's like do you know when you have a box full of tennis balls or shit? Do you know where they're cylindrical cases? Do you know the gap in between them? that won't be included, so we need to find that volume as well. So lads, what?
How can you find if you have absolutely nothing about, like, no information on it?
You can get information on it. Let me show you. Take it from an overhead point of view, and look something like this. I'll fit it in. It'll look something ever so slightly like this. I'll make it fit, so don't worry about that. Okay, then. Do you hear the term think outside the box? There you go. Now guys, that's roughly right, okay? Now, what did we say the diameter is from here to here? Huh? Yeah.
Oh, 7. Wait, so.
No, 10. The diameter is 10. The radius is 5. That's 10 centimeters. Aaron, do you know what you're doing now?
Yes.
Go for it, tell me.
So the diameter of the box is 20.
Not the diameter of the box, but the length of the box maybe?
Oh, yeah, the length of the box is.
Length of the box is now worth 20. What about the width of the box?
Would that be it'd be 10.
10. You know the width of the box is now 10. What do you know about the height of the box?
I know that would be 14.
Because it's the same height as the cylinders. Do you understand that? So what are the dimensions of the box? Width is 10, length is 20, height is 14. Find the internal volume of the box. What is the volume of the box? Length by width by, because it's the volume of the box, not the volume of the cylinders.
2,800.
Good man. So 20 times 10 by 14, and you said 2,800. Okay. Now guys, find the volume of air. So what volume does the cylinders not take up? 2,800 is the volume of the box. How much cylinders are there in the box? 2. What's the area of what's the volume of one cylinder? 1,000. So take away 1,100 twice. Do you understand what I'm saying? Because you have the area of the box and take away the area of your two 1,100s, and what do you get? There is 600 centimeters cubed of air inside the box. Is that right?